Hello my dear students, welcome back to Learn Physics. In today's video, we are going to continue with the dual nature of matter and radiation. Last class and all we were learning about the photoelectric effect. Right, here again we are coming back to the heading itself, dual nature of matter and radiation. So we know that radiation has already wave nature, and now the second nature is particle nature. So there in particle nature we considered the quantum theory of photoelectric effect, that is through Einstein's photoelectric equation. There when light rays are incidenting, we are considering the light as packets of energy. Right, it's a particle, so there we are considering light as particle. A particle of energy or packet of energy is falling on it. Its particle nature is called as photon. Photons gives the particle nature of light rays. So what are the characteristics of these photons? So it's having an energy. What will be the energy of this photon? E is equal to h nu. And what is the momentum? Momentum will be equal to h by lambda. Or we can write it as E by C, h nu by C. From h nu by C only we are getting it as h by lambda. This will be the momentum. Okay, so these are how this the energy of a photon depends on which quantity. Is it depending on the intensity? No, it's not. The energy of a photon is independent of its intensity. See, energy E is equal to h nu, or we can write it as E is equal to hc by lambda. Whether is it depending on the intensity? No, it's not depending on intensity. It's depending on the wavelength. Right, since it is depending on the wavelength, it is depending on the frequency also. E is equal to h nu. It's depending on frequency and wavelength. It is independent of the intensity of incident radiation. And what will be the velocity of this photon? Photon will be having the velocity is almost equal to the velocity of light. So then if we are considering it as it is almost equal to the velocity of light, what will be the rest mass? M is equal to m0 divided by root of 1 minus v square by c square. Right, so this will be equal to 0. Rest mass is considered as equal to 0. Now what about the energy of photon? Energy of photon, whether will it be changing from media to media? It won't be changing with respect to the media. Energy for a definite frequency, or while we are giving a particular frequency of radiation, it won't be changing the energy from in different medias. And what about the wavelength what about the speed of light, the speed of photon? The speed of photon will be varying, or velocity of the photon will be varying according, since the wavelength is changing. Wavelength of a wavelength is changing. Therefore, velocity v is equal to nu lambda. We know that v is equal to nu lambda. So if lambda is changing, according to that, velocity of the wave will be changing. But frequency of the wave will remain same. Therefore, the what will happen? Energy of the photon will remain the same. Energy, and this photon is not deflecting with the electric or magnetic radiation. So these are some of the characteristic properties of these photon. Okay, so photon are having a particular frequency and wavelength. E is equal to h nu. hc by lambda is the h by lambda is the momentum, and it is a conserved quantity. Moment, it's elastic collision only happening in the case of see photon electron collision. When it is happening, it is elastic collision only. That means the energy is conserved, and momentum also will be a conserved quantity, but the number of photons emitted also will be changing. But it is a energy and momentum are conserved quantities, since it is an elastic collision. And we know that here rest mass. What will be the rest mass of the photon? That rest mass will be equal to 0, since it is having the speed nearly equal to the velocity of light. right? So C by C, so it will be equal to 0, 1 minus 1 0, m into 0 is equal to 0, therefore rest mass is equal to 0. So these are the characteristic properties of photon. Okay, so photon means it's a packet of energy, it has particle nature, and its energy is h nu and momentum is h by lambda, and it is having the velocity same like a velocity of light. And the energy, what about the energy of the photon? Energy of the photon won't be changing from one media to another media since the frequency remains the same, but the velocity will be changing slightly depending on the wavelength with respect to the media. If as media changes, wavelength changes, according to that, this what will happen? The velocity will be changing. Rest mass is equal to 0, and in the case of itself, the elastic collision only will be happening. That means energy and momentum will be a conserved quantity. Okay, so these are about the characteristic of photon. And what are the, see, when we are considering the wave nature and particle nature, which is good for, what are the failures of wave theory in photoelectric emission? Next we are going to consider the failures of wave theory in photoelectric emission. So how can we see? First I am considering about the intensity. Okay, we know that intensity of light radiation is depending only on the emission of number of photoelectrons. Right? It is depending only for the number of photoelectrons. As intensity increases, number of photoelectrons increases. But as per wave theory, see, first I am considering the wave theory, intensity increasing. How we will be representing that intensity? Intensity will be represented with the help of this amplitude. As amplitude increasing, we will say it is the intensity also increasing. Amplitude increasing means what will happen? Yes, energy is increasing. Amplitude increases means energy will be increasing. Energy of photon will be increasing. If energy of photon increases, what will happen? The more number of photoelectrons will be emitted from that. Okay, so here it is depending on the intensity. Energy of photon is depending on the intensity of incident radiation. So as energy increases, what will happen? More energy is getting for the electrons in the metal surface. Okay, so it is acquiring more energy, and the electron will be coming out from the metal surface, and the rest of the energy, it will be helping the electron to move fast in the metal surface. Okay, but as per photo radiation experimental theory, we know that intensity of light is independent of the kinetic energy of electron. So first failure is, as per wave theory, if the intensity is increasing, energy of the radiation also will be increasing. Amplitude is increasing, that means energy is increasing. So if the light which is having more wavelength or more intensity is falling on the metal surface, it will be absorbed by the electrons on the metal surface, and it more energy is coming, right? So it will be helping the electron to come out from the metal surface. So as per wave theory, it is showing like as the energy is increasing, more number of electrons are emitting from the metal surface. So actually, is it doing so? No, it is not saying anything about the frequency, threshold frequency. It's not telling anything about the threshold frequency. It's telling that as the intensity is increasing, energy is increasing. So the electrons will be coming out, and after coming out from the metal surface, the next step which is happening is the electron will be moving from one end to the other end. When the electron is moving from one point to another point, the extra energy will be utilized for the movement of the electron. But actually, as per experimental observation, is it so? No, intensity doesn't have any dependence with the kinetic energy of the moving electron, right? So here these are the failures. And one more failure is there, that is, it is not dependent, it's an instantaneous process, we told. So photoelectric emission is an instantaneous process, but by wave theory we can say the energy or When the light radiation of particular intensity is falling on the metal surface, first that energy will be absorbed by the electrons, and after that, with the help of that energy, it will come out from the metal surface. But as per experimental observation, it is a instantaneous process, no time lag. So that also cannot be proved with the help of wave theory. So these are the three failures which we can discuss in the case of wave theory of light and photoelectric emission. So as per photoelectric emission, intensity doesn't have any dependence for the kinetic energy of the kinetic energy of the electron which is coming out from the metal surface. But wave theory says that as the intensity increases, amplitude is increasing. As amplitude increases, energy of the photon also will be increasing, and the electron which is coming out from the metal surface can move with the more speed. The kinetic energy is increasing. That's what telling in wave theory, but actually that is not happening as per experimental observation. And here they are not telling any dependence with the threshold frequency. As per wave theory, if we are looking into the photoelectric effect, as the intensity of light radiation increases, number of photoelectrons emitted also will increase. Right? But here we know that as per experimental observation, a minimum frequency, that is threshold frequency, is required for the electrons to come out from the metal surface. And the third point is it's an instantaneous process as per experimental observation, but by wave theory we can see that the electrons, the energy which is giving to the metal surface will be absorbed throughout the metal surface first, and then the electron which is getting more energy will be coming out from the metal surface. Okay, that's what happening in the case of wave theory, which is also not true as per experimental observation. Clear, children? So these are the three failures in wave theory of light. So next we are going to study about the dual nature of matter. So matter, already we know about the particle nature. Now we are going to consider about the wave nature of matter with de Broglie's theory. Next we are going to study about the de Broglie hypothesis of this matter waves. The matter has wave nature also. Such waves are called as matter waves. The wavelength of matter waves will be lambda equals h by mv, or we can write it as h by P. So by looking into this equation, we can say that lambda is inversely proportional to V and lambda is inversely proportional to mass. Okay, as mass of the particle matter is increasing, according to that wavelength will be decreasing. As the velocity of the matter is increasing, then also we can't say the wave nature. Wavelength is decreasing in both the cases. So mass of the matter should be very small to get the wave nature, and velocity of the particle also should be very less as per wave nature. If velocity is equal to 0, what will happen? This wavelength will be equal to infinity, and if velocity is equal to infinity, lambda will be a value tending to 0. That means the matter waves is included only if the matter is under motion. We can consider the position of matter. It's a matter as a wave only if the matter is under motion, and mass of the matter should also be very less to get the consider the wave nature. Okay, then this de Broglie hypothesis only helped to find out the Heisenberg's uncertainty principle, right? So is because of this wave nature, we can say the position of a particle is very difficult to find out the position of the particle. We can't predict the position and momentum of a particle simultaneously. That is, so somewhere in this wavelength, in this position, the matter is absurd. Like that we can say. So it is uncertainty principle. Position of a particle is very difficult to find out the exact position of the particle. Okay, so delta x into delta p is less than or equal to h by 2 pi. This is Heisenberg's uncertainty principle. So these are the here wavelength, de Broglie wavelength is very important. Lambda equals h by p. So in terms of temperature, how can we represent the de Broglie wavelength? We know that kinetic energy as per kinetic theory 3 by 2 kT. Okay. Now kinetic energy is equal to 3 by 2 kBT and kinetic energy equals half mv square, and here from here we can write it as V equals root 2 into kinetic energy divided by m. Okay, lambda equals h by p, h by mv, mass into velocity is root of 2 into kinetic energy by m, or h by root of 2m. Kinetic energy is 3 by 2 kT, right? So h by root 3m kT. And de Broglie wavelength of an electron, that is as per derivation we found out that 12.27 divided by root V angstrom. This is the de Broglie wavelength of electron. Lambda equals 12.27 divided by root V angstrom. Lambda equals h by p. In terms of temperature, lambda equals h by root 3m kT. K is the Boltzmann constant. Okay, clear children? So these are the theory part in dual nature of matter and radiation. Now we will see some of the numericals relating to this topic. So first question is, the kinetic energy of the electron orbiting in the first excited state of hydrogen atom is 3.4 electron volt. Determine the de Broglie wavelength and wavelength associated with it. Only kinetic energy is given. How can we find out? Kinetic energy equals 3.4 electron volt. That too in electron volt it is given. So we can convert that 3.4 into 1.6 into 10 to the power minus 19 joule. Okay, this is kinetic energy. We need to find out the de Broglie wavelength. Lambda h by p. Okay, h by mv. mv, how we can represent it in this kinetic energy? We know that kinetic energy equals half mv square. Okay, kinetic energy equals m into kinetic energy equals half m square v square. So p square by 2. Okay, so therefore P equals root of 2m into kinetic energy. Therefore H by root of 2m into kinetic energy. We can substitute the values. Planck's constant. M value also here it is given. It's 9.1 into 10 to the power minus 31. So usually in your question paper itself, at the starting of the question paper, they will be giving the relevant details. So you can find out the value by substituting the value of 3.4 into 1.6 into 10 to the power minus 19. Okay, so such kind of simple questions only can be expected from these portions. Okay, so I'll tell you one more question. An equivalent wavelength of a moving electron has same value as that of a photon having energy 6 into 10 to the power minus 17 joule. So energy is given like energy equals 6 into 10 to the power minus 17 joule, and calculate the momentum. We need to find out the momentum. Momentum, what is the formula? Lambda equals h by p. So p will be equal to h by lambda. What is h by lambda? We know that E is equal to h nu. hc by lambda. What is h by lambda? E by c. That is equal to E by c. E value is given 6 into 10 to the power minus 17. 6 into 10 to the power minus 17, and 3c is equal to 3 into 10 to the power 8. So here you will be getting it as 2 into 10 to the power minus 25 kilogram meter per second. That is momentum. Okay, like that. So simple equations only, simple numericals only will be coming from this portion. So I hope this portion is clear for you and it is simple only. In next class we will be continuing with the next chapter, which is atoms. So I hope today's video is useful for you, and if you like the channel, please don't forget to subscribe, like and share. Thank you for watching. Bye.